Learning Objective A, we're going to evaluate powers using properties of rational exponents, again without a calculator. So there's two things we want to remember though, is when you're given now an exponent that has more than just one number, because we were used to seeing the other day in notes like 9 to the 1/2 power. That we know just means the square root of 9 or 3. But what if they gave us 9 to the 3/2 power? So now we have this rational exponent that has integer values both at the top and the bottom. We have to evaluate this in 2 steps. What this little theorem here tells you is you can take the exponent and you can break it into 2 pieces. You can take it and you can pull out the top number or the numerator and pull it out by itself and then just do 1 over the denominator. Or you can pull that top number out and do that first and then just do 1 over the denominator. So for example, for this one right here, how we would do it is one of 2 ways. I could do 9 and I would pull the 3/2 apart. So I'm going to pull the 3 out and then do 1/2. I have 2 choices on how to deal with this exponent. I can either cube something and then take the square root, or I take the square root and then cube it. You get to pick and choose. So we could first do cubed, and then once we do that, take the square root. Or I could reverse it and say I'm going to do 9 to the 1/2 power first and then cube it. I'll tell you right now, I would need a calculator to do 9 cubed, so I'm going to this one first. The square root of 9 I know is 3, and then I would come in and cube that. 3 squared is 3 times 3 times 3, which is 27. So some of the times you can either do both methods easily, other times there will be just an obvious one to look at. So let's try this example. 64 to the 2/3 power. I'm going to take the 2/3 exponent there and just break it up. I'm going to pull the 2 out, so then I'm left with 2 and then 1/3, which means I have 2 choices. I can come to the number here of 64 and I can either square it and then take the cube root, or take the cube root and then square it. Again, if I first square it, then I do cube root, or it looks like to me the cube root is going to be easier to do without a calculator, because the cube root of 64 is what number 3 times is 64. That's going to be 4, and maybe I'm getting a calculator out to help me remember that. And then don't forget I have to square it. So 4 squared is not 8, it's 4 times 4, it's 16. If we were to do it this way, I would get my calculator to do 64 squared, but the cube root of that would actually be 16. Let's try this, 4 to the 3/2 power. Again, I'm going to take the 3/2 exponent and break it into a 3 and a 1/2. Now this one, I can either do 4 cubed and then a 1/2 power, or 4 to the 1/2 and cube it. Well, 4 cubed is 64, and then the 1/2 power means the square root, so it's 8. But here, the square root of 4 is just 2, and then if you cube it, that's also 8. Again, it doesn't matter which order that you do it. Before we dive into some more complex ones, let's review these 5 properties about powers. Remember when you have the base number here and then 2 exponents right next to each other, it means you multiply it together. Again, for example, you might have x cubed being squared. Be careful, by definition this means do x cubed 2 times. If you look at it that way, it might be easier to see that it would be become x to the 6th, so therefore clearer to notice you multiply those and don't add them. Then the product of powers here, when you have a base and an exponent times the same base and another exponent, you just add them. It's really just this right here. An x cubed times an x cubed, you'd add the exponents and get your 6. Now, what if you were dividing them out? So for example, if you had x to the 5th divided by x squared, what you would do is you have 5 on the top, 2 on the bottom. You technically subtract them, and that's all they're saying here. So in this case, we'd have x cubed. This 4th rule, if you have 2 different base numbers in here and an exponent on the outside, you can, in theory, distribute that or give it to both numbers that are the bases. So what you might have is, if it's 3x being squared, what you would do is you would write 3 squared and x squared or 9x squared. And the same thing, if it's a fraction but they're two different bases, the b or the exponent would go here. So let's just reverse that. What if we had written 3 over x, all being squared? You would just give the square to both the top, so it would be 3 squared over x squared, or 9 over x squared. So when you see something like this, it's actually more difficult to visualize, because if we had, for example, 2 to the 4th times 2 squared, we know we add those exponents, but we can visualize that. Well, in this case, you have to realize you do add the exponents. So it's going to become the same base number of 2, but we're going to do 4/3 plus 2/3. Now remember, when you add fractions, you just need a common denominator. So this just becomes 2 to the 6 over 3. 6 over 3 is just 2, so 2 squared is the answer, which really simplifies to 4. Two other very important theorems. This one here says you have a base raised to any 0 power, it's always going to equal 1. So if you had 8 to the 0 power, you had 5,716 to the 0 power, if you had z to the 0 power, all three of these equal 1. The other thing is, if you have a negative exponent that is not considered simplified, to get rid of a negative exponent, just put it over 1, make it a fraction. And anytime you come over here and you cross over the fraction bar, the sign of the exponent changes. So if it was negative on the top, when you bring it to the bottom, it becomes positive like here. So if we look at this one right here, they want us to simplify 8 to the negative 1/3 power. Now the first thing I do is get rid of all negative exponents. So I'm going to put this over 1, and I'm going to bring this down. Now be careful, there still is something on the top. It's a 1. And this is 8 to the 1/3. Now, I remember 8 to the 1/3 just means what number 3 times gives me 8. That in itself is 2, so the answer here is the number 1/2. This is a nice combination of a few things. Let's simplify and keep it as a fraction. So you're not going to want to type this in your calculator, because on a test or quiz, you'd have to show the work on how to get this. But it's 49 to the negative 3/2 power. Again, first thing I want to do is get rid of that negative exponent, so I can make any number by a fraction by putting it over 1 and bringing it down. So now I have 1 over 49 to the 3/2 power. I'm going to take that 3/2 and I'm going to pull it apart into 3 and 1/2. And if I'm doing this without a calculator, I think it's more logical for me to come on here and do 49 to the 1/2 power first and then cube that answer. This just says the square root of 49. The square root of 49 is just 7, and then it's cubed. Now 7 cubed I may not know by heart. I probably would get my calculator out for that, but 7 cubed is going to be 343, and this is going to be 1 over that number, and that's our final answer. This is a nice extension of just a basic algebra concept of putting things in increasing order. First of all, remember, increasing means from smallest to largest, and they want you to put these in order. It would just be based on the exponent, basically. So the problem is, here we have an integer, here we have a combination of a radical, and then we have a decimal. I want to see these all in the same format. So what I'm going to do is just rewrite them as decimal exponents. So x squared is still x squared, and x to the 2.8 decimal is still that. This one right here, what this actually becomes though, be careful, this is the cube root of x to the 5th. When you rewrite that, x to the 5th, the cube root is that. So remember, what do you do in this case of those exponents? You multiply them together. So this is going to be x to the 5/3 power. Now I am going to make that a decimal so I can understand it better. If I put that in my calculator, the decimal is going to be 1.67. So I'm going to put that right here. This one right here is going to be similar fashion. Be careful though, this x to the square root is x to the 1/2. Then there's a 7 on the outside. So I'm going to multiply that. It becomes x to the 7/2. And that is just going to be written as x to the 3.5 decimal. Now in increasing order, let's do the smallest one first. That would be the second variable. And do write it like it originally was stated. So we're going to put the cube root of x to the 5th first. The next one is going to be x squared. and then x to the 2.8 power. Lastly, this one here, and I am going to put it in its original format. So it's going to be the square root of x to the 7th power. Now this question is just going to have us think backwards a little bit. They want us to write this expression here as a power of 2. Currently this is a power of 1/2, and I need to make that 1/2 a 2. I can make that number a 2 by bringing the 2 upward. Now be careful, this is a 2 to the first power, so when I bring that up, what happens is it becomes 2 to the -1 power. And then it's just raised to the n divided by 12 power. Now do simplify. Remember here, these two exponents, you're just going to multiply them together. So this becomes 2 to the -n over 12th power. And it is written as a base number or a power of 2.